Hello everybody, and welcome to exercise 5 on page 53 of the workbook. And here's an example of a little bit more of an abstract nature. Let's read this together. So they're telling us that f is a differentiable function. We don't know what it is. Differentiable just means that it has a derivative. And let g of x be f of the square root of x all cubed. Okay, and part A would like us to take the derivative of that function g. And what's kind of abstract about this is that we're being asked to take the derivative even though we don't know specifically what the function f is. Okay, we can still come up with a formula for the derivative in terms of this function f that we don't know the value of. Okay, so same question that we've been asking ourselves in other problems. Okay, when you look at the function g of x, what kind of a form do you see there? Thinking about our rules for derivatives, which rule do you think would apply to this situation? Okay, well, I notice that we've got kind of an inside-outside function situation. If you think of the f of the square root of x as being a u, g of x looks like u cubed. That tells us that we probably need to use the chain rule at the first part. Okay, so let's do that. So our whole function looks like u cubed. How do you take the derivative of u cubed? Well, that's a power rule. You just get 3u squared, and our u is f of the square root of x. Okay, so we're going to get 3 f of the square root of x squared. Okay, and the second part of the chain rule is to multiply by the derivative of the u, which in our case is f of the square root of x. Okay, so we are done with the first part, 3 f of the square root of x squared, nothing more to do with that. But we do need to take the derivative of f of the square root of x. Okay, how do we do that? Well, notice that we again have an inside-outside situation. This time, it's the square root of x that's being substituted into f. Okay, so if you think of this as being f of u, how would you write down the derivative of f of u? Well, we don't know what the function f is, so about the best we can do is to write f prime of u. Okay, so f prime of the square root of x, and again, since it's a chain rule, we still have to multiply by the derivative of the square root of x. Okay, so we've used the chain rule twice. Let's rewrite the part of the problem that we're done with. Okay, and to finish, we need to take the derivative of the square root of x. Well, we've seen this a few times already. The square root of x is really just x to the 1/2. So when we take its derivative, we're going to use the power rule and just get 1/2 x to the negative 1/2. Okay, and that's as far as we can go, and so that's the best we can do as far as writing down a formula for the derivative of g. There's our answer to A. Okay, let's take a look at B then. So in B, they would like us to use the values in the table to calculate a numerical value for g prime of 4. Okay, so they're giving us some information about the function f, this function that we don't have an explicit formula for. Right? Well, how would we do that? How would we find g prime of 4? Well, that's really just asking us to substitute the number 4 in for x, and we have a formula for g prime of x back up here in part A. So basically what we need to do is to just take x equals 4 and substitute it into that formula. So I'm going to do that. Everywhere we see an x, we're going to put a 4. 4 to the negative 1/2. Okay, and notice one thing that happens here. Square root of 4 shows up in a couple of places. The square root of 4 is just 2, so how about if we go ahead and just write that down? Okay, and then what about this 1/2 times 4 to the negative 1/2 over here at the end? Could we get a number for that? That's really 1/2, and then 4 to the negative 1/2, that's 1 over 4 to the 1/2, which is really 1 over the square root of 4, okay, if you rewrite it. So what we've got on the end there is basically 1 over 2 times 1 over 2. That's going to put a 1 over 4. That entire circled part simplifies to 1 over 4. Okay, and what's left is see if we can figure out numbers for the missing pieces. So for example, f of 2, is there a way that we can get a number for that? Notice that that's sitting in our table. Okay, f of 2 is equal to 1. Okay, so we can fill that in. And then what about f prime of 2? Okay, notice that that number is also in our table. It's sitting right here. It's negative 2. Okay, so we've broken this down into numbers, and last thing to do is just simplify and see what we get here. So 3 times 1 squared is 3 times negative 2 is negative 6. Okay, and finally, multiply those fractions, we get negative 6 over 4, which simplifies to negative 3 over 2, and that is our answer.